Hi guys, I hope you are all doing well. Let's see today's question. So today's question we are taking this up from the topic of limits. And if I talk about the question that is given to us here, the question tells us to find the value or evaluate the value of a limit which is n tends to infinity. And the expression given to us here it says 1 square minus 1 times n minus 1 plus 2 square minus 2 times n minus 2 plus till we have to find out this when it is n minus 1 the whole square minus n minus 1 times 1. So we need to figure out that, and that whole thing is divided by 1 cube plus 2 cube plus doing it till n cube minus 1 square plus 2 square plus doing it till n square. So we have to figure out the entire value of this. And if I talk about the answer choices that we have been given here, the options are 2 over 3, 1 over 2, 3 over 4, and the last answer choice we have been given here is 1 over 3. So we need to figure out which one of the answer choices is the correct answer for the question that is given to us here. Let's see how to solve this question further. Before starting off with the solution for this question, I'd first like to tell you that please do subscribe to my channel and support the channel as well, because it takes lots of efforts in making these videos for you, and it is free for you but also motivates me to put up better content and try to make the solutions as easy as possible. Let's see how to solve this question further. So if I just evaluate my numerator and my denominator, both of them separately, let's do that. So numerator, if I just evaluate here, I have been given 1 square minus 1 times n minus 1, 2 square minus 2 times n minus 2. This goes on till n minus 1 the whole square minus n minus 1 times 1. So we have to basically find the sum of this entire thing. So if I just evaluate and write it in the terms of summation, I can write summation of r equals, this goes from 1. So I can just write as r equals 1, and this goes till n minus 1. So n minus 1. Now if I try to write the general term for this entire expression that I've been given here, the pattern is I have 1 square minus 1, then 2 square minus 2, like that, I have to go till n minus 1 the whole square minus n minus 1. So if I have the r going from 1 to n minus 1, I can just write it in the form as r square minus r. So you get 1 square minus 1, you get 2 square minus 2, then 3 square minus 3, and so on till n minus 1 the whole square minus n minus 1. And further, if I see the second bracket here, it goes from n minus 1, decreasing it by 1 every next term, and this goes till 1. So I understand this is n minus r, because r goes from 1 till n minus 1. So I can just write this 1 as n minus n minus 1. That basically leaves me with only 1. So this is my whole general term I have here. Summation, if I see, it goes from r equals 1 to n minus 1. If I multiply the whole brackets, what do I get? R square n minus r square into r, which is r cube, minus r into n, minus r into minus r is plus r square. So we have this entire term with us. Now if I see the summation, I get r equals 1 to n minus 1. If I write it in the form of a descending order or descending powers, I have the highest power, which is minus r cube. For r square, I have two terms. So if I take r square common, I get n plus 1. And then only the term of r is left, which is minus nr. So we have this entire thing with us. If I try to evaluate each of them separately, I can just write them as summation r equals 1 to n minus 1. The first one is minus r cube plus summation of r equals 1 to n minus 1. The next term is r squares, sum you're finding, and n plus 1 being a constant, I'll just take it out. So n plus 1. And the last term I have is minus nr. So minus n and summation of r equals 1 to n minus 1 r. So we have all of the summations that we need to figure out here. Let's try to evaluate them. So if I try to evaluate them, we know that summation of n terms, if I want to find out, summation of terms, I know it is n into n plus 1 over 2. When if I say summation of r terms, basically when n goes from 1 to, or r goes from 1 to n, Then if I have to find summation of r equals 1 to n for r square, so sum of squares of n terms, it's basically given by n times n plus 1 times 2n plus 1 over 6. And if I find the summation of r equals 1 to n for r cube, so sum of the cubes of n terms, if I find out consecutively, I get them as n into n plus 1 over 2, the whole square. So we have all of these summations. If I use them here, I know here we have to be cautious about this, that r does not go from 1 to n. It just goes till n minus 1. So everywhere I have put n here, we have to substitute instead of n, we have to substitute them as n minus 1. So if I just use that idea here, minus r cube I have to figure out. So minus, I'm taking it just out. And summation of r cube from 1 to n minus 1, if I have to do, instead of n everywhere, I'll just put n minus 1. So it gives me n minus 1, n minus 1 plus 1 over 2, the whole square. Then plus n plus 1, summation of r equals 1 to n minus 1 of r square, if I have to figure out. You have to again do till n minus 1. So you have to just substitute instead of n minus 1 everywhere. So I get n minus 1, n minus 1 plus 1, which is basically n. Then I have 2 times n minus 1 plus 1. The whole thing divided by 6. And the last term I have here is minus n. Summation of r equals 1 to n minus 1 for r terms. So that basically becomes n minus 1, n minus 1 plus 1 divided by. So we have this entire term list with us. Let's try to evaluate this. So minus n minus 1. I have this is n over 2, the whole square. Plus here if I see, I have n plus 1, n minus 1, n 2n minus 2 plus 1, which is 2n minus 1 over 6. And the last term I have here is minus n, n minus 1 into n over 2. So we have this entire numerator. So this is basically what your numerator looks like. Let's try to evaluate our denominator as well. So if I figure out the denominator here, let's do that. So denominator basically becomes here sum of the cubes of n terms. Sorry, denominator. So that basically becomes 1 cube plus 2 cube plus goes on till n cube. Now be cautious here, it does not go till n minus 1 terms only, it goes till n terms, so n cube. And subtracted also with the sum of the squares, which also goes till n terms, so n squared. So if I just evaluate this, this basically becomes n into n plus 1 over 2, the whole square, minus sum of the squares will basically become n into n plus 1 into 2n plus 1 over 6. So we have this with us. We have our numerator, we have our denominator. Now, once I have them, I know that I have to find the value of the limit where n tends till infinity. And whenever n tends till infinity, if I take an example for you to understand here, let's take a very common example. So if I try to evaluate the highest power of numerator and denominator first, I can see n squared and n minus 1 squared. So highest power is going to be 4 here. Here I have 4 terms multiplied of n. So the highest power of that is going to be 4. And here the highest power is going to be 3. So overall for the entire numerator, the highest power is 4. And if I try to evaluate the highest power of the denominator, it's going to be n square and n plus 1 the whole square. So the highest power is going to be 4 here. Whereas for here, I am just multiplying 3 terms with the variable n, which has the power 1. So the highest power is 3. So the highest power for the entire denominator is going to be 4. So I have my numerator, I have my denominator. Both of them have the highest powers 4. Since both of them have the highest power, which is same, if I take an example, let's take an example and solve this. So if I have, let's say, x square plus x over, let's say, 3x square minus 4x plus 1, where limit n tends to infinity, how do we solve this type of questions? We just divide by the highest powers. So I divide by x square in both sides for numerator and denominator. That leaves me with limit n tends to infinity. X square over x square, which is 1, plus x over x square, which is 1 over x. Here x tends to infinity. Let's not take n tends to infinity. So here also it will become 3x square over x square, which is 3, minus 4x over x square, which is minus 4 over x, plus 1 over x square. So we have this. And when I have x tends to infinity, I get this 1 plus 1 over infinity, which is 0. 3 minus 4 over infinity, which is 0. 1 over infinity squared, which is 1 over infinity, which is again 0. So I get this is 1 over 3. So I get this idea when x tends to infinity that I have my answer 1 over 3 for this example. So what do I make a conclusion out of this here is, if I have my numerator and my denominator and both of them have the highest powers same, then your answer for this entire limit becomes the coefficients of the highest power. So if I see the coefficient of the highest power of numerator, it is 1, and the coefficient of the highest power of the denominator, it is 3. So that makes the answer 1 over 3. So I get the answer for this type of questions as 1 over 3, since both of them have the highest power same. Here also I have the highest power of numerator 4 and the highest power of denominator 4. So the only thing that we have to do is not multiply all of them. We have to just find the coefficients of the highest powers. That is, we have to find the coefficient of the highest powers, which is x raised to 4 or n raised to 4 for the given question. So if I just do them and then divide the highest powers, so limit n tends to infinity. If I just find the coefficients of n raised to 4 for both of them, so here if I see it's going to be minus n squared and n squared, which will become n raised to 4. So I'll have this 2 in the denominator. So minus half would be my value for the highest power. So it will become minus half n raised to 4 something. And for the second also, if I see for the numerator, I have this n, n, and 2n multiplied. So if I multiply those first terms only, I get 2n raised to 4 over 6. So I have that n raised to 4 over 6. So 2n raised to 4 over 6, I have this coefficient also for n raised to 4. So for numerator, I think these are the only two terms, because the third term gives me the highest power as n cube. So that becomes minus half and n cube. So that does not work. So we don't need this, but we need this too. We took care of that. And if I talk about the denominator, so denominator, if I see n square and n plus 1 the whole square will also make n square, which is over 2 squared, which is 1 over 4. And here also it was actually 2 squared. So it should be taken minus 1 over 4, not 1 over 2. So we should make a change here, minus 1 over 4. This is divided by, here also if I talk about denominator, it is n square into n plus 1 the whole square over 4. So the highest power of fourth power would become 1 over 4. So I have for the denominator 1 over 4 n raised to 4. So this will be the idea, and then you will have n cube terms and n square terms and so on. Now we know that whenever limit of something tends to infinity, and if you have both the highest powers same for numerator and denominator, you just take the coefficients of them. So if I solve for the coefficients there, I have minus 1 over 4 plus 2 over 6. The whole thing is divided with 1 over 4. If I solve for this, I get minus 1 over 4 plus 2 over 6. I can just make this as 1 over 3. The whole thing divided with 1 over 4. So if I make the coefficients or the denominator same for the numerator, I multiply this with 4 and this with 3. Gives me 4 minus 3, which is 1. 1 over 12, 1 over 4. That basically makes it 4 over 12, and that makes it 1 over 3. So we get the answer to the question as 1 over 3. And if I see that matches with which answer choice? D. So D becomes the correct answer for the question that is given to us here. I hope you have understood how to solve this type of questions, which deals with the ideas of finding the limits of an expression where the variable tends to infinity. I'll see you again tomorrow with some other question from some other topic. And we are going to continue our series of questions on JEE mains. So stay tuned for more videos to roll out. Also, if you're enjoying these videos that we are doing on everyday basis, please do like the videos as well and do subscribe to my channel and share this channel with your friends also who are involved in the preparation of questions on JEE. So they can also take the benefit from these questions that we are solving. Thank you.